Hello, everyone. Today we are going to begin our discussion associated with testing hypotheses or the aspect of hypothesis testing. For those of you following along with the chapters in your Graviter textbook, we are now covering Chapter 8 for the semester. Our semester is going by pretty quickly, to be honest. I wish time was slowing down for us and we'd be taking a lot longer in terms of covering some of the material, but our time is flying by. And I'm sure you all are very excited to and looking forward to November and wrapping up the semester in December associated with our course. So let's go ahead and begin our discussions for today in terms of hypothesis testing. And in terms of what are we talking about for hypothesis testing. Now, aside from just our chapter reading for this week, I have also posted an additional chapter for you guys to read in terms of hypothesis testing that I think is a little bit more of a simplified version in terms of understanding what hypothesis testing is. I'm going to go through a lot of examples with the discussion of hypothesis testing. There's a lot of examples that come from your Chapter 8 textbook reading. And then there's going to be lots of examples that we're going to cover in terms of hypothesis testing as the following weeks come up in terms of the semester. Okay, so when we think about hypothesis testing, the very first thing that we have to think about is going back to the initial relationships that we have between descriptive and inferential statistics. So just to make sure that we're all on the same page in terms of what we're talking about with descriptive and inferential stats, remember that descriptive stats, they describe our samples of individuals. Our inferential stats, they are trying to infer about the population, okay? That's what we're trying to do. Now, in both of these situations, these are both statistics, okay? So these are both stats in both of our cases. Now, why is it important that I bring up this point about both of them being statistics? Well, it's important that we talk about them both as being statistics because when we think about descriptive statistics, we are talking about samples. Remember that from samples, we calculate statistics. We don't calculate calculate parameters from samples. Parameters come from populations. So descriptive statistics, these are measures that are used to describe your samples. So what are we talking about here? We're talking about measures of central tendency like the mean, median, and mode. We're talking about measures of variability like standard deviation, range, variance, etc. And then when we move over to the aspect of inferential statistics, now what are we trying to do? We're now trying to infer about the population using your sample. So in other words, I have a population, whatever my population size is, right? So capital N. And from there, what I do is I randomly sample individuals, right? That would be my ideal situation where I randomly sample. Now, is that always going to be feasible for me? I don't really know, to be honest with you. So more than likely, I'm probably not always going to randomly sample. More than likely, what I'm going to end up doing is I'm going to end up using what's called a convenient sample. What is a convenient sample? That means that it is a group of individuals who I assume represent the population, but who are readily available to me. I've used this example in the past already, but I'll use it one more time here. Assume here that I am interested in collecting some data about individuals, about how they perceive statistics courses. So one of the things that I could do is I could potentially go and find every single person in the world who's taking a statistics class or who's going to be enrolled in a statistics class next semester and randomly sample from that entire population of individuals. And then from there, I give them out my questionnaire. From there, I collect my data and I do all my assessments that I actually need, etc., etc., etc. But yet here, rather than me actually doing that, since I know it's probably not going to be feasible for me to do, on the other hand, what I'm going to go ahead and try to do in this particular situation is I'm just going to go to people who I know who are potentially going to take statistics next semester. So for instance, let's say I know 50 people here on campus who are going to take statistics next semester. So from those 50 individuals, I may potentially sample from them. So I may give the 50 individuals all an equal opportunity to participate, but yet only 20 people come in. So I had easy access to those 50 individuals because I know them, they're on campus, they may be students of mine from another course that I know that they're going to take statistics in the future, so thus they are conveniently available to me. That's why we call it convenient sampling. So in reality, I don't do true random sampling because I didn't give everyone from the population an equal opportunity to participate. I just gave some people the opportunity to do that. So in any case, to be honest with you, we do convenient sampling unforgivingly. So in other words, we really don't sit around and worry about not having done true random sampling. And I don't stay up at night crying, thinking to myself, oh no, I didn't do true random sampling. I'm a terrible researcher. To be honest, 99% of us probably do convenient sampling because it's a lot easier for us to actually do those kinds of studies in where we get people who are easily accessible to us. When you actually look at the psychological literature in terms of the discipline of psychology, anything that's really done in terms of the field of psychology that's not like practice orientated, so in other words, that's not actually done like in a clinical setting, but more that's done for experimental purposes like research in cognitive psychology, research in social psychology, and personality psychology, etc. A lot of those studies actually use college students. So why did we use college students? Why didn't we go out to Walmart or to HEB and randomly sample from individuals from there and give those individuals an equal opportunity to participate? Because it's pretty hard to do that. So instead, I just go through and I say, okay, well, I have people in general psychology. I needed them to participate in my research study. I'm going to go ahead and have them participate by offering them extra credit for an assignment, for instance. So we have, out of 100 people, 20 people come in and they give us their data. So again, here we have a convenient sampling opportunity in that option. So what's my point of discussing this issue of convenient sampling and the aspect of random sampling is that we assume here from the population we're going to get sample size. So in reality, this is what we're working with. We're working with individuals from the sample. We're not working with individuals from the population. So I don't have the population at hand. I have a sample of individuals. Now I assume that this sample of individuals is a pretty good representation of the population, right? That's what I'm going to hope for here. Now the more people that I have in my sample, the better representation I'm going to have in terms of my population. Okay, and that's going to be very important for me. So the more individuals that I have from my sample, representing the population, the better representation of the population as a whole I'm going to have. So in other words, if the population, let's say, equaled 1,000 individuals, and we end up sampling, I don't know, let's say 100, and here I don't know why my numbers didn't come out. Let's see. Okay, let's see what's happening with my numbers. So in the case where we have more individuals participating in our study, as in the case here that we have, for instance, if we have a population that's 1,000 individuals and we get 20 people to participate in our study, well, that's some representation of the population. But in an ideal world, if I get 200 people to participate in my study rather than 20 individuals, I'm going to have much better representation of the population than I did in this particular instance. And why? Because I have more of the population being represented in this particular case. And that's ultimately what I want to try to do. So if, for instance, I have 20 people participate and my population is 1,000 individuals, I have about 2% of the population, 2% of the population participating. Now, if I have 200 individuals participating and my population is 1,000, I'm going to have a lot more individuals participating in this particular case. So in this particular case, now we're going to have 20% of the population participating in our particular study. So here I obviously have a better representation with 200 individuals rather than just 20 individuals. Now, can I get away with just having 20 individuals? Yeah, probably, to be honest with you, depending on the purpose of the research study, depending on where it is that I want to try to get it published. Maybe this is a pilot study, so this is just an initial study phase that I want to work with, rather than it being a full-fledged study that I actually want to take out into the real world and try to publish and try to describe my results in terms of how it affects the real world population or something along those lines. So depending on what it is that the purposes that I want to do with my study, having 20 individuals participate may not really be a bad idea, but having 200 people may be an ideal situation. So when we think about the relationship between descriptive and inferential statistics, we have to think about it in this particular way. So when we think about descriptive statistics are here to help us summarize information about my sample. So again, we're going to calculate things like the mean, median, and mode, standard deviation, variance, range, information about who it is that I'm working with in terms of my sample. So information about that group that I'm actually working with. Now, do remember, and this is a very important thing that you always have to consider, is let's say that you're working with two groups, right? So let's assume here that you're going to be comparing groups. So one group, for instance, is a strict online class. and another group is going to be traditional, in-person class. So here, ultimately, what you want to do is you want to evaluate them on, let's say, an exam score, right? So we calculate an average for exam scores for the online class, and they get a value of an 85. And for the traditional class, they get a score of an 80. Now, if you notice here, I calculated a descriptive statistic for the online group and a descriptive stat for the traditional group. So I calculated an average for online and an average for traditional. This means that when I also calculate standard deviation, I'm going to calculate a standard deviation for each group. So here, whatever my standard deviation is, I'm going to calculate one standard deviation for the online group, one standard deviation for the traditional group. So this is very, very important in terms of our understanding of descriptive statistics, that whenever it is that we collect data and we calculate descriptive statistics, we are describing the sample here that we're working with. So the descriptive statistics refer to that one group. I have other descriptive statistics that refer to this group. So in other words, I don't have one average for both groups. I don't have one standard deviation for both groups because that wouldn't make intuitive sense, to be honest with you. Why would I want an average that looks at everyone's scores who are online and traditional? I don't want that. I want an average exam score for people who just took online, average exam score for just traditional students. I want a standard deviation for just online and a standard deviation for just traditional. Why would I want separate means and standard deviations? Well, because our groups are different. So here we have a different manipulation in this particular case that may have been given to students in this particular instance, such as them taking an online class versus them taking a traditional class. So here the average for the exam for an online class is separate from the average of a person taking a traditional class. Even though they received the exact same exam, we still have to keep their averages separate because they were treated differently. So in different manipulations, they were treated differently, thus we have to keep their descriptive statistics separate. And we're going to calculate a different standard deviation for each one of our groups in those particular cases. So when we calculate descriptive statistics, what's the point of calculating descriptive stats? Just so that way we can describe and summarize information about our sample. And now the next thing we want to try to do is we want to try to infer about the population. Now, even though here I'm saying I infer about the population, do remember that I'm still talking about inferential statistics. So here's the term, statistics. So I'm still talking about inferring about the population using who? We're using the sample, and that's always a very important thing that you have to consider in terms of your work with statistics. That again, very rarely do I ever work with the population, and I know that many of you in terms of your discussion board post have talked about, oh, we would really like to see more of the formulas for the populations and things like that, which I agree with you. Knowing the formulas for the populations is probably going to be, just good knowledge for you to have, but to be honest, practicality or practically speaking, for practicality purposes, you're really never going to be using the population formulas, to be honest with you. Very rarely, if ever, will you use a population formula. And why? Because again, I don't work with the population, I work with the sample. So in other words, I talk about my sample, and then I infer about the population using my sample. So in other words, I'm going to calculate other types of statistics, not descriptive statistics. I'm going to calculate inferential statistics that are going to allow me to draw conclusions about the population. What conclusions am I talking about? I'm talking about the null hypothesis, and I'm talking about the alternative hypothesis. Two very, very important predictions that we're going to talk about during lecture for today. So again, remember, with inferential stats, I'm drawing conclusions about the population using the sample. So what conclusions am I drawing about the population? I'm drawing the conclusions about the null and the alternative hypothesis, and we're going to talk about those further. So here again, just to kind of reiterate and talk about this relationship between populations and samples, think about the relationship between populations and samples in the following way. I took this figure directly from your textbook from the probability section, or the probability chapter that we covered for last week's module. In terms of thinking of the relationship between the two is the following. So whenever it is that we are talking about the population and we want to then talk about the sample, there's a probability here that goes associated with that. Why is it that there's a probability associated with this relationship between the population and the sample? Is that when I draw individuals from the population, right, if I'm doing random sampling, when I draw individuals from the population, there's a probability that they may be representative of the population, and they is a possibility or a probability that they may not be representative of that population. So that's something that we do have to consider. Now, whenever it is that we're drawing conclusions about the population using my samples, that's where inferential statistics are really going to come into play. So here, under this text box of samples, you can imagine here that we're going to have things like our descriptive stats. So I'm going to have things like my mean, my median, my mode. I'm going to have also standard deviation. I'm going to have variance, whatever it is that you want. You can have also range. So information about the sample, okay? So things that relate to the sample. Now, using the sample, I'm going to draw conclusions about the population. What conclusions am I going to draw? I'm going to draw conclusions about the null, and I'm going to draw conclusions about the alternative hypothesis. So we're going to be talking about using inferential statistics to draw those conclusions. Now, for the remainder of the semester, this is what we're really going to be talking about, and this is going to be very important because a lot of the things that we're going to talk about are very theoretical in their nature. So in other words, they're difficult for us to get a little bit of grasp on because we really can't see them in terms of, oh, I'm trying to do their calculations, which you can do a lot of manual calculations if you would like to. We're really not going to focus on too much of that, to be honest. It would take too much time to do the calculations of inferential statistics all semester long, to be honest. So in reality, I'm going to talk about the theoretical component. I'm going to show you how it is that we actually do our statistical analyses, and then talk about that relationship between whatever it is that we calculated in terms of my data collection and then drawing conclusions about the population in terms of the null and the alternative hypothesis. So think of the following. So what we're doing is we're going out, we're collecting data. So we're going to collect data. And then what we're going to do is we're going to analyze that data. So we're going to analyze data. And then from our analysis, we're going to draw conclusions. So we're going to draw conclusions about the null and the alternative hypothesis. Okay, that's what we're going to do. And the purpose of this lecture today is to talk exactly about that, to talk about how it is that we draw conclusions about the null and the alternative hypothesis, because they are very, very important for us. So when we think again about the population, here we're talking about the entire group of individuals who we have an interest over. So for instance, my research studies, they don't just apply to individuals who came in and participated. I'm using those individuals' data that came in and participated to talk about the population. So if we're talking about, for instance, Spanish-English bilinguals, we're talking about everyone who is a Spanish-English bilingual. So in other words, it doesn't matter if they know Spanish from Spain or that kind of dialectical difference from the Spanish they speak in Mexico. If they know Spanish and also English, no matter what countries they're from, they can still go ahead and be able to participate in my research study. If they come from Mexico and they know Spanish and they also know English, we're still going to allow them to participate because they technically fit those parameters of Spanish-English in those particular cases, right? Because they're still part of the population. But what happens in the case where they speak Spanish and French? Well, then they're not a part of my population. Even though they are considered to be bilingual, they're not the Spanish-English that I really am looking for. So in that particular case, anyone who fits those characteristics of being Spanish and English bilinguals then must meet or have that criteria then to be able to participate in my study. So they are going to be part of that population. Now, am I going to use everyone? No, again, I'm really not going to use everyone. So rather what I'm going to do is I'm going to get a sample of individuals to come in and participate. In other words, these are going to be people who are going to be a point of the or part of the population who participate in this study. And here, rather than saying point, that should say part of the population. I don't know why I wrote point in that particular instance. I think I was trying to say point estimate, representation of the population parameter. But ultimately here, for our sample, we're talking about part of the population who is actually going to come in and participate in my study. So again, remember from them, I'm actually going to be taking statistics. So from the population, I take parameters. Those are the values that I calculate associated with the population. So in other words, the population average, such as mu, the standard deviation for the population, which is sigma in our particular case. When we take values from samples, we're going to call those statistics. So we have things like x bar, My bar should be over the x, not to the side. I do apologize for that. We're going to have things like S, our standard deviation, and on R, for instance, like our correlation coefficient that we're going to talk a little bit about later on in the semester. So again, very important, this relationship between the two. So in other words, we're going to be working with our sample, but we're going to be inferring about the population. And again, what are we going to be inferring about the population? We're going to be talking about the null and the alternative hypothesis. So remember again that whenever it is that we actually calculate statistics, statistics are going to be used as point estimate representations of population parameters, and we're going to be using those statistics that we calculate in the process of hypothesis testing. So in other words, when I actually try to test the null and the alternative hypothesis, and in reality I shouldn't say the null and the alternative, I should really just say the null hypothesis, and I'll talk about why only the null a little bit later on. When we're testing the null hypothesis, we're going to be using statistics to estimate parameters. That's essentially what we're going to be doing, okay? Because remember, just like everything else that we've been talking about this semester, if I calculate a sample statistic such as x bar is going to be equal to mu. So in other words, I'm going to assume that the average that I calculate for my sample is going to be a point estimate representation for my population parameter associated with the group average for the population in this particular case. The same thing happens for standard deviation. I calculate standard deviation for my sample. I'm going to be able to infer about the population standard deviation because I have a value that supposedly represents the population because it's a value that's coming from a sample, and the sample themselves represents the population. Okay, so let's here briefly talk about this idea of hypotheses. Now, I always like to talk about 3 different types of hypotheses, and the reason I talk about 3 different types of hypotheses is because, again, I like to see the relationship between statistics and also research methods. So this is a very important thing that I think we need to talk about in this particular instance before we continue on. Again, I mentioned this at the beginning of the semester that the purpose of statistics is to answer questions, okay? So stats answer questions for me. Why do they answer questions? Well, they answer questions for the following reasons. That I'm going to be able to find out information about, for instance, groups differing. So if I'm comparing group 1 and group 2, my online versus my traditional class, and I look at the differences between their scores, and I find that their scores are different in terms of their averages, and I find that there's an extreme difference between their scores, I'm going to be able to then draw conclusions that there is something different about the way that they perform. So there is something different about online versus traditional in-class participation in terms of exam scores. Okay, and how am I going to draw that conclusion? I'm going to draw that conclusion because I'm going to calculate statistics, and I had an overarching question. What was my overarching question? My overarching question maybe was something like, is there a difference between online versus traditional classes in terms of exam performance? If that's my question, I now need to be able to test that question. How do I test that question? I test that question by first trying to establish a prediction. Once I establish that prediction, then I can move on, calculate statistics. Once I calculate my statistics, I can test hypotheses. Once I test the hypotheses, then I'm going to be able to go back and answer my question. So there's a very, very important relationship between statistics and research methodology. So in other words, from my question, I need to make a prediction. What is a formal term that we use for a prediction? We're going to call this a hypothesis. Okay? A hypothesis. Now, what is a hypothesis? And here you probably know a general definition of a hypothesis. You probably heard of a hypothesis being called an educated guess. I'm going to go ahead and stop you right now and tell you that I don't like that definition. And one of the reasons that I don't like that definition of a hypothesis being an educated guess is that, to be honest with you, there is no guessing that happens in terms of research. One of the things that we do as researchers is we want to be pretty certain that something is going to happen. So imagine when we build experiments, right? So when we're going to make a research study and we're going to go out and we're going to collect data, a lot of things go behind that creation. So we're going to go ahead and we're going to spend money, spend time, which in some instances also translates into money. We're going to go ahead and spend also resources in terms of collecting data, analyzing the data, writing those papers up, etc., etc., etc. So a lot of energy goes into the buildup of this idea of trying to design a research study. So here, think of something like your cell phone. So with your cell phone, for instance, do you think somebody would just go out on a limb and just say, okay, well, I think this will work? Probably not, right? Because to make a cell phone, it costs a lot of money to make a cell phone, right? Especially the prototypes of a cell phone. So it's not something that's going to be inexpensive and it's not going to take up too much time. It's probably going to take a lot of time. It's probably going to be somewhat expensive at its initial prototype phases, et cetera, et cetera, et cetera, right? So here what we want to do is if you're a person who wants to make a cell phone or who wants to write a computer program or who wants to answer a question such as, is there a difference between online and traditional students in terms of their exam performance? You already want to go in there with an idea if they are going to be different or if they're not going to be different. So rather than saying that a prediction is an educated guess, what is a hypothesis? A hypothesis is going to be defined as the following: a prediction based on previous evidence. So a prediction based on previous evidence. Prediction from previous evidence, if you would like. Okay? Now, what does that mean? A prediction based on previous evidence essentially means the following. We already have people who've been doing research in our given area. Now here, I'm not saying you're going to be replicating their work, right? That's what I'm not talking about. Many years ago, I heard someone once say that the purpose of research was to replicate. And I almost threw a rock at them. And I really didn't throw a rock at them, right? And I almost did not really throw a rock at them either. It was the illusionary rock that I wanted to throw at this person. And it made me kind of upset that they said that the purpose of research was to replicate. And I thought to myself, well, what is the purpose of research? Is the purpose of research really just to sit there and recreate somebody else's experiment and confirm their work? I mean, I'm already expecting that if you're going to go out and you're going to design a research study and you're going to implement it out into the real world, I'm going to assume here that you're going to try to do a really good job with that. I'm not going to assume that you're going to do crappy work, if you want to think about it in that sense, that you're not going to do shoddy work, that you're not going to not do your statistics appropriately, that you're going to mess around with your data and make it look like something else, but rather you are going to be honest and you're going to give us the best answer that's actually out there. So in reality, what is then the purpose of study if it's not to replicate somebody's work? The purpose of research really is to discover something that we don't know about yet. So in other words, I want to answer a question that I don't know the answer to. That's really what I want to do as a researcher. I think the best way that I think I've ever had research kind of explained to me, or the idea of what the purpose of research was. There's a virologist by the last name of Wolf who has a book that's called The Viral Storm. And if you ever get a chance to read this book, The Viral Storm, you can go ahead and purchase that book. I have no royalties that come my way, so I won't tell you to buy it or not buy it. But if you ever get a chance to read it, you can go ahead and read it. And he talks about what the purpose of research is in terms of trying to understand viruses and things like that. And he had a very interesting quote in the book. And he said, the purpose of research is not to discover what makes us comfortable, but rather to discover the truth. And I kind of just closed the book for a minute and I kind of thought about that. And I said to myself, you know what? He is exactly right. That is exactly what the purpose of research is. The purpose of research is for us not to discover what makes me comfortable. Because to be honest, there's a lot of times that we do research and we find very uncomfortable answers. So for instance, people do research and we find out that sometimes people, for instance, out in the real world are still prejudiced. That's an uncomfortable topic. We don't like to think about the idea that people discriminate each other based on their religion, based on their ethnicity, based on their gender, based on their socioeconomic status, based on the clothing that they wear, etc., etc., etc. We don't want to think about that, right? We want to think that we live in this world that's all the color of roses and it smells beautiful and everyone's amazing to each other and everyone is super helpful and there's social justice for everybody. But in reality, that's not really the case, right? So we find things that make us uncomfortable. So for instance, think of also the following. Do we know that there are uh, that there is drug use. Yes, there is absolutely drug use. So is that something that's uncomfortable? Yeah, right. Because we kind of don't want to think about those kinds of things. We want to sometimes say, no, people don't really use drugs. The incidence of drug use may be going down, but in reality, is the incidence of drug use going up? Is it staying the same? Is it going down? I mean, that's a very important question that we need to answer. And why? Well, because if the incidence of drug use is going up, maybe we need to create intervention programs that actually help people try to get into rehabilitation centers and actually solve or help themselves in those situations to try to kind of alleviate them from being addicted to specific drugs. Or if drug use is going down, but we're pouring in billions and billions and billions of dollars that aren't getting used up into rehabilitation centers, that may be something of interest too for us to do some research on. Well, there's less drug use going on. Maybe we don't actually have to have so many rehabilitation centers, or maybe we could be doing other types of treatment techniques that may be as expensive, but yet they're going to be much more efficient than trying to diversify and use all those funds to everybody who's actually out there seeking treatment. Now we're going to use a little bit of a more expensive strategy on these individuals and help them overcome their addictions a lot faster. So ultimately here, we need to be able to continue to do research, even on the uncomfortable topics. Why? Well, because it's answering our questions for us. We as a race, right? So us as humanity, one of our biggest questions is about us. So why is it that we do these kinds of things? What is my purpose here? Why is it that people act this specific way? The majority of you who are psychology students or who are psychology majors or minors probably have asked your question about an individual in a very similar fashion. Why is it that someone acts in this particular fashion? Why is it that people become addicted to drugs? Why is it that there is domestic disputes and that can potentially then lead to child abuse or to spousal abuse? Why is it that X, Y, and Z? So we ask these questions. So we ask those questions, what's the next logical thing? Well, if we ask a question, now we want to make a prediction. So again, is that prediction going to be based on just my guess, on my supposition? No, absolutely not. But rather it's going to be based on previous evidence. So in other words, other people out there in the field are also doing research, and they've told you that there have been things that have already happened. So maybe they're not asking the exact question that you are. They're asking a little bit of a different question, but yet they still kind of touch upon your topic. So for instance, have research studies been done that look at the differences between traditional and online courses in terms of exam performance or in terms of academic achievement? The answer is yes, tons of times. But what if, for the very first time, now someone is using a platform like something like YouTube, and we're now disseminating our information to these individuals who are our students, and they easily access the information from anywhere they want at any point in time that they want, that they can pause, rewind easily from any of their mobile devices, that they don't even have to have wireless, that they can do it over their provider's internet service ability or whatever the case may be. So what if we're now trying to investigate a research question that's a little bit different? So it's still the question about online versus traditional, but now it's just a little bit modified. So other researchers maybe didn't talk about the use of YouTube and other online platforms. They just talked about traditional versus online. But now we have a researcher like myself who's saying, okay, well, what if we use online, such as using YouTube, having homework assignments that are all digital, having all the feedback given by the professor as being all digital, and there's really no paper trail that we've ever really made for this class. So if you guys have thought about it, what have we really printed out this semester except for the textbooks that have been printed? Nothing, right? Everything else has been digital that I've been trying to do for you guys this semester. So very few things have actually been printed. So what if we're asking that question? But like I mentioned, other researchers have already been looking at the differences between traditional and online. So they say, okay, well, we know that online versus traditional students perform at X. So online students have an average of X, and traditional students have exam performance of X as well, right? So let's say that online for exam number 1, they perform at an 85. Traditional, they perform at an 80. So now I come in with my new research question, right? Where I say, okay, we're going to use online, but we're going to be using all these online platforms. We're going to be using things like YouTube and digital videos and digital multimedia players, et cetera, et cetera, et cetera. So now I have my question as well. So previous researchers told me that this is the difference that they saw. and that we would expect if we were to to actually combine or compare online versus traditional, right? So in other words, someone already did research on online versus traditional in the past, and they said this is the difference that should exist. I now come along, make a modification to the idea of online versus traditional. It's still the same conceptual idea of online versus traditional, but now my online is just a little bit different from their definition of online. So now, what would I expect? Would I expect then that the averages between online and traditional to flip? So in other words, traditional performs better than online performs better than traditional, or they don't differ? Based on previous evidence, so based on these researchers' findings, I would still predict that online would perform better than traditional. So traditional would perform lower than online. And why? Why would I predict that? Why would I think that would happen? Because previous researchers have been telling me that that's what should be happening. Take another example for the following. If you've ever been stuck in the sand, like at the beach, right, or you've heard of people being stuck in the sand, one of the things that happens, so for instance, I live very close to the beach here, and I see this happen all the time where people get stuck, their vehicle stuck in the sand. And one of the things that I think is quite funny is that someone will get stuck in the sand, and they'll sit in their car and they'll keep pressing the accelerator. So if you know anything about being caught in the sand, or even if you've ever seen a movie where somebody's been caught in the sand or in the mud, for instance, you know that once your tire is in there and you keep pressing the accelerator, you're really not going to go anywhere. Your tire's just going to spin. If anything, you're going to sink in a little bit further. So rather here, a lot of individuals, what they'll do is they'll be like, oh man, okay, so I'm stuck in the sand. I tried pressing the accelerator. I didn't go anywhere. And they'll kind of get out of their car. They'll look, kind of assess the situation. Then they'll get back in their car and they'll press the accelerator again. And they don't go anywhere. And they kind of are surprised, I didn't go anywhere. I wonder why I didn't go anywhere. It's like, well, yeah, man, you're not going to go anywhere because you didn't do anything different. You were already caught in the sand. You had pressed the accelerator once. You didn't go anywhere. You got out, looked, didn't do anything to change your situation, went back in your car, pressed the accelerator again, and again, did not go anywhere. Of course you weren't going to go anywhere. Previous experience had already told you you weren't going to go anywhere. So now here, what do you need to do? Well, you get caught in the sand or stuck in the mud or stuck in the sand, whatever you want. And you get out of your car and you say, okay, well, I'm stuck in the sand. I need to do something to change my situation. Maybe I'm going to put some rocks underneath the tire or as deep down as I can get it, close to the tire in the mud, so that way I can give my tire just a little bit of traction to see if it can kind of jump out of the mud or out of the sand. So you put a couple of rocks in there, right? But you go and you find these tiny little pebbles. So you put these tiny little pebbles in, next to your tire and to the mud, and you press the accelerator and you don't go anywhere. And you say to yourself, okay, man, I tried putting a couple of rocks in there and I didn't go anywhere. What do I need to do now? Well, maybe if I put some bigger rocks, okay, put some bigger rocks under there, and maybe now your car starts going just a little bit, but it still doesn't get out. Right? So you're like, okay, well, I was going somewhere there. What if I put more rocks? Or what if I get this, big wooden, 2x4 and I stick it into my, right underneath my tire, and maybe that will give it enough traction to kind of pop out. Whatever the case may be. So here, my point is the following. You're doing things now differently. You're implementing new treatments, new manipulations to see if you can get your car out of the mud. That's the purpose of research, for us to try new things to see if we can get out of the mud faster or that we can get out more efficiently. So in other words, it's okay to keep looking at this question about traditional versus online if we continue to make modifications to the definitions. So in other words, we find, based on previous experience, that whenever it is that people take online courses, they do better than traditional courses. Well, what if we now provide them with all this multimedia information? Will they perform even better than traditional students again? And we find that the answer is also yes, they do. Perfect. So now we have two research studies that tell me that online performs better than traditional. So now the next researcher comes along and they say, hey, you know what? There's this brand new software that came out that's supposed to help students learn even faster and more efficiently for an exam if they're taking an online class. So now let's implement that new software technology into an online setting, and we're going to compare online versus traditional again, who are not using that software. So here, based on previous experience, so in other words, based on previous research, we find that online traditionally performs better than traditional. So now here I'm implementing this new treatment, this new software that's supposed to make them even better students and have higher grades. I'm again going to predict the same thing, that online is going to perform better than traditional students. Okay? That's really what a hypothesis is. My hypothesis is not, well, I'm going to guess. No, don't guess. Think about what others have done and what others have said and what evidence they have to base your prediction on that. That's really what a hypothesis is, a prediction based on previous evidence. So now let's talk about our different types of hypotheses. Now, statistically speaking, there are two types of hypotheses that we're going to talk about. What we call the null hypothesis and what we also call the alternative hypothesis. Now, the null hypothesis predicts the following. The null hypothesis predicts no effect, no difference, right? So no difference, or no relationship. That is what the null hypothesis predicts. No effect, no difference, no relationship. Now here, symbolically speaking, the null hypothesis predicts the following. If we're comparing group 1 and group 2, right? So let's say online versus traditional, it would be mu1 is equal to mu2 or mu1 minus mu2 is equal to 0. Okay, so in other words, the difference between mu1 and mu2 is going to be equal to 0, or mu1 is equal to mu2, and the difference between those two averages is equal to 0. Now, if you do notice, the null hypothesis is symbolically stated in terms of population parameters. Okay, so population parameters. Oops. So a population parameter. Now, why is it symbolically stated in terms of population parameters? Because remember, your null hypothesis talks about the population. So it's inferring about the population. So we use sample statistics to infer about the population, but what about the population? About the null and the alternative. The null and the alternative refer to the population. So in other words, in the real world, this is what I expect to happen. Either the null is going to be true or the alternative would be true. The alternative hypothesis predicts the alternative of the null hypothesis. If the null hypothesis predicted no effect, no difference, no relationship, the alternative predicts that there is an effect, there is a difference, there is a relationship. Okay? So here, the difference between mu1 and mu2 would exist. So in other words, mu1 is not equal to mu2, or mu1 minus mu2 is not equal to 0. Okay, which is very important. So mu1 minus mu2 is not equal to 0. So in our particular case here, the difference between mu1 and mu2 is not equal to 0, or mu1 is not equal to mu2, which is then not equal to 0. Now, if you do notice, I do have this other symbol here. Now, do not get this symbol here confused with my p statistic. This is not p, okay? Very, very important. This term is called rho, so R-H-O. Now, later on in the semester, we're going to talk about a very special statistic that we call the correlation coefficient, which we use lowercase r to refer to correlation coefficient. This is why I told you when we talked about the range not to use lowercase r, because lowercase r was reserved for our correlation coefficient. R, lowercase r, is my sample statistic. Rho, which is that symbol there, refers to the population parameter associated with the relationship statistic. So in other words, R is equal to rho, such as my sample mean, x bar or capital M, was equal to my population parameter of mu. Okay? So x bar is equal to the population parameter of mu, right? Rho is the same thing as saying R, but in terms of a population parameter. So R is my sample statistic, rho is my population parameter. So in our particular case here, we're saying that the difference between the two groups is equal to 0, or that rho, the relationship is equal to 0. Now you'll notice that there's a major trend between all of these. We have the 0 right here that's appearing. Now here I do provide you with the null hypothesis for my z statistic. Now here I know you all are like, okay, like we thought we were all totally done with z. We covered z with z-stat. We covered z with probability, and now you're talking about z again, man. Like, what is wrong with you? Just stop it. Last time that I'm going to talk about z this semester, I promise you. So here in your textbook for chapter 8, Graviter and Walnu talk a lot about this idea of the z distribution and hypothesis testing associated with z. That's why I'm going to talk about it here. Normally, I do not talk about z, the z statistic in terms of in terms of hypothesis testing, but here, since your book talks about it, I do want to talk about it here briefly because I don't want you all to think that I'm leaving anything out from the textbook or that you get confused with what it is that I'm talking about. So the things that I normally talk about, for instance, I talk about the T statistic or the F statistic or the R statistic. As we go through the semester and we introduce those statistics, I'm going to begin to introduce hypothesis testing associated with them. But essentially the process is exactly the same for all statistics. Okay, so here it doesn't even matter if we talk about Z or if we talk about T or if we talk about R, it doesn't really matter for us. So in terms of Z, what does the Z statistic predict? So here the Z statistic would predict that everyone's score in terms of the data set would be equal to 0 in terms of a z-score. So in other words, everyone's raw score would be equal to 0. Not that the raw score is equal to 0, but rather the z-score is equal to 0. In other words, the raw score is equal to the mean. Okay? So in other words, z is equal to 0 because the raw score is equal to the mean. Okay? Because remember, that's what we meant by a z-score equaling 0. That your raw score, so one individual person's raw score, was equal to the mean. If your score was equal to the mean, then z would be equal to 0, right? So here, we would assume then that the difference between my mean and my score and the mean would be equal to 0. But now here, it's assuming the following in terms of, again, a theoretical idea, that the difference between my sample mean and my population mean would be equal to 0. Okay? So here, think of it in terms of the following. Think of Z saying the following. X minus the mean would be equal to 0. Okay? But now here, we're saying that the difference between the sample mean and the population mean would be equal to 0, because here now it's assuming that it's looking at the entire data set. So it's assuming here that everyone's z-score is equal to the mean. Okay? So in other words, the mean minus the population mean would be equal to 0 in this particular case. So again here, all that we're saying is the following. That if we were to have a z-score being equal to 0, my score would be equal to my mean. So if we have 10 scores in my data set, that would mean that we would also assume that every score in my data set would be equal to each other, which would then be equal to the mean. So then we would assume that if we're looking at the difference between the mean and the population mean, right, so the sample mean versus the population mean, we would also assume then that the difference between my sample mean and the population mean would be equal to 0. Okay? That's ultimately what z-scores are trying to tell us. The difference between my score and the sample mean in terms of standard deviations. But now here, the way that we're going to use with hypothesis testing is we're going to be looking at the difference between my sample mean and the population mean, and z would assume that the difference between those two would be equal to 0. Okay? So in other words, out there in the population, my mean should be equal to X value. In my sample, my average should be equal then to the mean. So in other words, my sample mean is equal to the population mean, thus the difference between those two values would be equal to 0. That's ultimately what we're trying to say here in our particular case. The alternative hypothesis predicts the opposite of the null hypothesis. So in other words, the alternative hypothesis predicts that there will be an effect, there will be a difference, there will be a relationship. So in our particular case, if we were looking at the differences between two groups, so again, online versus traditional, mu1 minus mu2 would not be equal to 0, or mu1 is not equal to mu2, thus the difference between the two groups would not be equal to 0, or rho would not be equal to 0, and in the case of z, we're ultimately going to say then that my scores are not going to be equal to the mean, right? So z is going to be equal to something else other than 0. What value? I don't know, but it's just not 0. And thus, the difference between my mean and the population mean would not be equal to 0. Okay? Now, what happens in the case where we would find one result versus the other result? Okay, if we find the null result, right, or the null hypothesis, this is not a bad thing, okay? And this is very, very important for us to think about in terms of research and in terms of statistical responses. The term bad really doesn't exist for us statistically, okay? And why doesn't the term bad happen or exist? Because the term bad refers to something psychological in its nature. So in other words, the interpretation of the results may be bad or good. So in other words, let's say that we were looking at the differences between two ethnic groups to see if they're helped more than the other. So we're looking at the differences between Caucasian and Hispanic individuals in terms of how much they're helped in an emergency situation. And we find that Caucasian individuals are helped more than Hispanic individuals. So there, we would find that there's a difference between the groups, but yet the finding is bad, right? And the finding is bad because, oh man, that sucks. There's differences in terms of how much they're helped, thus indicating prejudice, which is a bad thing, right? But here, if we find that there is a difference between the groups, again, we're not assuming here that that is bad. We're just saying that the alternative hypothesis would be true in that instance. That, for instance, in that particular example, individuals are not helped equally in terms of one group versus the other group, which is what the alternative hypothesis would predict, that the groups do differ. The null hypothesis would predict that the groups don't differ. In our online versus our traditional example here, we would assume that the null hypothesis would predict that the differences between online versus traditional in terms of exam scores would not exist. There would be no difference between the two groups. Their averages would be equal to each other. The alternative hypothesis would predict the opposite of the null. The alternative hypothesis predicts that online courses versus traditional courses do differ. How much do they differ by? The alternative hypothesis doesn't give me a value. All it tells me is that they should not be equal to each other. So in other words, the population average for group 1 versus the population average for group 2 should not be equal to each other, but I don't know what that value is. All I know is that it's not equal to 0. Okay, and that's a very, very important thing that we have to consider here. So again, we're assuming that with the alternative hypothesis, it's saying group 1 is not equal to group 2, thus the difference between the groups is not equal to 0. Then what is the value equal to? I don't know, it's just not equal to 0. Because again, remember, the null and the alternative hypothesis, these are theoretical results that exist out in the real world, okay? So if you think about this here, the null hypothesis is really the only one that gives me a value. What value does the null hypothesis tell me that the answer should be? If we're looking at differences between groups, it tells me that the differences between the groups should be equal to 0. If we're looking at relationships, it's telling me that the relationship value should be equal to 0. Z, for instance, the difference between the sample mean and the population mean is equal to 0 in this particular case. Right? So it gives me a value. The value that it gives me is a 0. So it gives me something to work with. So in this entire universe where the null and the alternative hypothesis exist, the only true value that I know that really does exist is the value given to me by the null hypothesis, which is my value of a 0, because it's telling me again that there should be no differences between the groups, there should be no relationship, there should be no effect, or there should be no difference between the sample mean and the population mean, thus the differences between those two values should be equal to 0. The alternative hypothesis, on the other hand, tells me that the differences should not be equal to 0. It should be something else other than 0. What is that other value? I do not know, and I cannot know that until I do research to see if the alternative is true. Okay? So remember, The alternative and the null hypothesis, they refer to the population because these are things that we assume exist out in the real world. Now, again, of the two, the null and the alternative, which is the one that provides me with a value? The null provides me with the value, and that value is a 0. The alternative provides me with an unknown. I don't know what that value is. I just know it's not supposed to be a 0. Okay? So very, very important for us to keep those straight in this particular case. Okay, now the third hypothesis here that I want to introduce to you is not a statistical hypothesis. This refers to our research hypothesis. So in other words, this hypothesis here that I want to talk to you guys about is essentially that hypothesis there that I've introduced for you. So in other words, what is a prediction? What is a hypothesis? This is the prediction that we as the researchers believe is going to be supported. Now, this research hypothesis ties in very, very closely to the null and the alternative hypothesis because of the following reasons. So going back to our online versus our traditional example, think about this situation here. We said that a previous researcher had looked at the differences between online versus traditional, and they found that the groups differed. We are now doing a research study, and we're now comparing online versus traditional. We're not replicating the study, we're extending it, asking the next logical question in the line of research, but yet, based on these researchers' findings, I should now be able to make a prediction. So based on these previous researchers' findings, that online performed better than traditional, what would I then predict in my research study if I'm also comparing online versus traditional, and I'm just using a new platform for online? I would also predict that online would do better than traditional. Why? Because based on these people's previous work and their findings, I should then draw a very similar conclusion. So in other words, these people got out of the sand by doing the following. I would assume that if I do what they did, plus a little bit more, I should be able to also get out of the sand and potentially even increase scores even further in that particular case. So in other words, I predict that there's going to be a difference between online versus traditional classes in terms of exam scores. That's the prediction that I think is going to happen. So in other words, that's the result that I think is going to happen. But now listen very closely to what I'm saying. I predict that there's a difference between online versus traditional courses. So I predict that there will be a difference between online versus traditional courses in terms of exam performance. Of the null and the alternative, which is the one that I'm saying should happen? The null or the alternative? So again, I said there will be a difference between the two. So of these two, which one is it that I'm saying is going to happen? The null or the alternative? The answer is, I'm saying that the alternative is going to be supported in this particular instance. In other words, I'm saying that the group should differ. In other words, the difference between mu1 and mu2 should not be equal to 0. What's the value going to be equal to? I don't know, but it's just not going to be equal to 0. That's what I'm predicting. Now let's say, for instance, that previous researchers had found that group 1, so online, and traditional did not differ. So that's what previous researchers had said, that they did not differ. So in other words, they did a research study, they found that groups did not differ. Okay? Based on their work, what should I then predict? Should I automatically then predict that the groups will differ based on the opposite of their result? Or again, should I base myself off of their work and say, okay, well, they did this, I'm doing this tiny modification, but I don't know if that modification may be enough to actually produce differences in the scores. Maybe it is, maybe it's not. But here, I don't know if it's going to be enough. I don't have any research that tells me that the new manipulation that I'm creating is going to be sufficient to create differences. So based on the previous researchers' work, that they found no differences, I'm going to predict that groups are not going to differ. So in other words, using an online platform like YouTube is not going to increase performance for exam scores for students versus those who are taking traditional. Why? Well, potentially, for instance, putting videos on YouTube may allow the students to continue to view other videos that are on the sidebar and distract them from the material that's actually being presented in the lecture. So thus, using an online platform like YouTube may not really be efficient because it creates too much distractions, thus then not creating any better situation in terms of exam performance. Okay, so there, based on the previous researcher's assessment that groups did not differ, I now predict that groups don't differ. I'm now saying that the null hypothesis should be true in that instance. Because based on previous research findings, groups did not differ. I'm now predicting that groups won't differ. Why did I predict that? Because remember, your prediction is based on previous evidence. So in other words, based on what others have done, you should then be able to draw those conclusions. So in other words, you're stuck in the sand. Other researchers were also stuck in the sand. They put tiny little pebbles underneath the rock, or sorry, tiny little pebbles underneath the tire. It was not enough for them to get out, so thus they found no differences between not using anything and using that system. Now, you grabbing 3 pebbles versus 2 pebbles, again, may not be enough. So in other words, it's not enough for me to use just 2 little pebbles or 3 pebbles versus the pebbles that they used. I may need to use a larger rock, or I may need to use a wooden board. So based on the wooden board's research and based on these previous researchers finding also that they found no differences, I should then be able to draw a conclusion about what should happen with my work. Okay? So ultimately, what is a research hypothesis? What we label RH. Okay? So from now on, you're going to see me use RH a lot. This is what we're going to call research hypothesis. Okay? This is my research hypothesis, the prediction that I think is going to actually be supported in our research studies. So there's a huge issue here of debate, the difference between a research and an alternative hypothesis. Many textbooks, statistics textbooks, and research methods textbooks will say the following, that the alternative hypothesis is always the same thing as the research hypothesis. So in other words, many research textbooks and statistics textbooks tell you that if you're a researcher, you should automatically always be predicting the alternative result. So in other words, no matter what you do in your research study, you should always be predicting that the groups are going to differ, or that there is going to be a relationship, or that the mean and mu will not be equal to 0. Does that sound right? To say that anything that you do, no matter what you do, is going to produce a better result, or is going to actually have group differences? To be honest, to me, that says no. So in reality, they're not the same thing. Now, this is my perspective. If you feel different about that, that's fine. But do remember, I'm the one that grades your exam. So for this class purposes, you're going to have to agree with me in this particular case. But if you're in another class and the professor tells you the research and the alternative hypothesis are the same thing, that's understandable because they're the ones who are teaching you that class. But I'm telling you that they're not the same thing. Why? Because if researchers have been telling me all along that groups don't differ, the groups don't differ, or that treatment doesn't work, why now me making a small modification to the treatment, will that be sufficient to it actually produce different results? And the answer is, I don't know. Maybe it is, maybe it's not. So here, for instance, again, researchers used 2 little tiny pebbles under the tire to try to get the tire out of the sand. But now you, rather than using 2 pebbles, you're going to use 3 pebbles. Is that manipulation really going to be sufficient enough for you to warrant to say that the groups are going to differ? That it's going to be sufficient to help your tire get out of the sand? I would argue no, it's not. There really is no strong theoretical justification that tells you that 3 little pebbles are going to help you enough to get enough traction to get out of the sand. Maybe it will, I don't know. That's why we do research. But my prediction, my assumption would probably be, no, it's not enough. Because these other researchers use 2, you're using 1 little more, it's not enough. Now if you tell me, well, I'm using 2 little pebbles and I'm using a very large 2x4 under the tire, I would say, you know what? Now I think you can definitely predict the alternative. That's probably going to warrant enough for you to say that it's going to make a difference between the groups. So in other words, here using that strong of a manipulation may be sufficient. But again, here, just making a tiny modification may not be enough. So the research hypothesis may potentially be the null hypothesis, depending on what previous researchers have been telling you to do. Okay, that's very, very important. So here, for me, I do not believe that the research and the alternative hypotheses are the same thing. Because now, just me creating a new research study and adding in a manipulation doesn't necessarily mean that they should differ. Take another example here if you want another example. Let's say, for instance, we have a drug that cost $1 million to make. one pill, okay? And it's going to help alleviate the symptoms of this disease. Okay, so we have one pill that costs us $1 million to make, but it alleviates all the symptoms of a specific disease, whatever disease you would like, right? So then I come up with a new drug that costs me $1 to make, and it's as efficient in reducing the number of symptoms for that disease as the $1 million drug. Okay? So in other words, there is a $1 million plug, right? So there's a plug. There's a $1 million pill. So it costs $1 million to make this one pill. And now I'm telling you that my pill cost $1 to make, and it's enough to create the exact same results as your $1 million pill. So in other words, people who take the $1 million pill, they show an average number of symptoms to be equal to 2. Okay, so in a 24-hour period, they show 2 symptoms with the $1 million drug. With the $1 drug, they show 2 symptoms as well. So now here, is there a difference between the two groups? The answer is no. Okay? So in other words, I found the null hypothesis. I found that there is no difference between the $1 million pill and the $1 pill in terms of their effectiveness to reduce the symptoms of this particular disease. So in our particular case here, what should I then conclude? I conclude that the null hypothesis is true. I found no difference. That's a good result. That was excellent. So in other words, my chemistry behind the creation of my medication was exactly the same as the $1 million pill, but it cost me less to make. Thus, it produced the exact same results, and I assumed it would produce the exact same results because it's doing the exact same thing as that pill. Thus, I would have predicted that the null hypothesis was going to be true. I was predicting that the group should have not differed in terms of the number of symptoms that they were actually displaying in a 24-hour period because my drug and that other drug is doing the exact same thing. So in other words, I predicted that there should have been no difference. I find no difference. So me finding no group differences was a good thing because here it's actually good that my $1 pill is as efficient as the $1 million pill because it costs less for us to make. All right, so let's go ahead and begin talking about the aspect of significance testing. Now, very, very important, we need to talk about a very, very important key term here. The key term that we're going to talk about is this term significant. So here, this term significant is going to be used pretty much from here on out to the end of the semester in terms of your research careers, in terms of your professional careers. It doesn't really matter in what discipline it is that you go to. This term significant is going to be coming up a lot. Now, the term significant is a term that is very, very frequently misused. And why is it that it's frequently misused? Because people don't really understand what the term significant means. In research situations, a lot of times you're going to hear people talk about, well, this is a significant finding. What does that mean? This is a significant finding. People normally interpret a significant finding as being, this is an important finding. But to us in research and in statistical testing specifically, the term significant means a very, very important thing. The term significant for us in terms of statistical testing means extreme enough for us to interpret. So whenever it is that we say there are significant differences between the groups, we are essentially saying there are extreme differences between the groups for us to be able to then conclude that the groups are really different. That is what we're really trying to say. So rather than us saying, well, the difference between the groups is important, that is not what we're saying here. What we're saying is the differences between the groups are large enough or extreme enough for us to interpret for them to be considered to be different. So in other words, if we find a situation where there's a difference between an 81 and an 80, would you consider that difference to be extreme? Your answer here would probably be no. Those differences are not really extreme. My question now becomes, how do you know that? How do you know that the differences between an 81 and an 80 are not extreme. So for instance, if your fellow classmate says to you, hey, what did you get in your exam? And you say, I got an 80. And they say, well, I got an 81. I'm significantly smarter than you are. Would you buy that? Would you actually say, you know what? You're right. I think you are you are smarter than me. You are extremely smarter than me. Would you buy that? And the answer would probably be like, no. There's a difference of 1 point. That difference of 1 point could be due to a ton of different things. It may have been due to the instructor potentially grading yours differently than theirs. It may have been due that they studied 1 more minute than you did. It may have been that you forgot to answer that question and they didn't. Who knows? There's a million different reasons why the difference between 81 and 80 existed that really don't consider to be extreme. But what happens in the case where somebody gets an 81 on the exam and another person gets a 70 on the exam? Would you now consider the differences between these two values to be extreme? Your answer would probably be yes, they are. And why would they now, in this particular case, be considered to be extreme? And you would say, well, because the differences between these two values seem to be pretty large. So if somebody comes up to you and says, what did you get on the exam? And you say, well, I got an 81, and they say, well, I got a 70, it's okay for you to then say, I know more of the material than they do, or I, not necessarily extremely smarter than they are, but I know more material or extreme enough difference of material for me to consider that I know more about statistics than they do. And the reason here is that this difference seems to be larger. But now one of the things that we want to talk about is this aspect. We never want to do this in both cases. We never want to look at our data and eyeball data. One of the very first things that you'll ever learn about research and about interpretation of data, because this is your very first lesson here, is now what I'm teaching you. The very first lesson that I'm going to teach you in terms of interpretation of data is never eyeball data. Never look at your numbers and be like, yeah, that's a difference. How do I then know what really is a difference? Well, the term null hypothesis significance testing now comes into effect, where we are now going to be looking at our numbers and seeing if those numbers are extremely different from each other for us to be able to draw conclusions that the groups do differ. So in other words, if we're looking at the difference between, let's say, online, like we were talking about, versus traditional, and we find that for online, their average was a value of an 85, and for traditional, their average was an 80, I want to know if the difference between these two numbers is extreme enough for me to consider them for them to be extremely different, or significantly different would be the term that we would use. So I need to know, are the differences between a value of an 80 to an 85 extremely different from each other for me to then draw the conclusion that the groups do truly differ? That's what I'm going to try to do. So rather than just looking at these numbers and saying there's a difference between 80 and an 85, yeah, we're good. No, we're never going to do that. Because maybe the difference between an 80 and an 85 is really not true. Maybe it's a very small difference, to be honest with you. Why is it a small difference? Well, who knows? Maybe the standard deviations for the groups play a part, because they do. What happens in the case where there's a lot of error variance? Does that play a part? Absolutely. So ultimately here, I need to be able to draw conclusions about this aspect of a difference between an 80 to an 85 and know for certain if the groups do truly differ or not. Why would I want to do this? Think of a following example. I'll give you an example that happened many years ago to a friend of mine. A friend of mine was working for an institution in the country, and one of the things that they wanted to do is they wanted to see how their enrollments change from one year to the next, right? For university, that's a very important thing. So the university that this individual was working for had thousands and thousands of students. So they had something like almost like 15 or 20,000 students. So let's say, for instance, in, I don't know, and here I'm just making these numbers up, in fall of '05, let's say that the university had 14,000 students, okay? And in fall '06, the university now had 14,000 and 10 students. So essentially what my fellow researcher here got asked to do was to write a report about these two numbers. So my colleague here wrote the report and essentially said, all right, well, from follow 5 to follow 6, we had an increase of 10 students. Not a significant increase. That's what they said. And here, my colleague interpreted that as saying it's not an extreme increase. So when you look at those numbers between 14,000 and 14,010, don't interpret that increase in 10 as being impactful. So don't interpret it as being extreme. Don't look at that 10 and be like, oh no, we're growing exponentially. We need to do something about it. So he takes this report and he presents it to his boss, and his boss presents it to other bosses, and so on and so forth. And all of a sudden, my fellow colleague receives a call from the university, and they say, hey, we need you to give a presentation to the president at this point. And he gives a presentation and shows them the numbers and says, we're really not growing. We're pretty much remaining the same. And the president of the university says, no, but we've gone up by 10 people. We're growing. And my colleague here looks at the numbers and looks at the president and everybody else in the room, and everybody's, yeah, absolutely, we're growing. And my colleague here is looking and going, no, we're not growing. We've only gone up by 10 people. That's not an extreme increase from one year to the next. He's like, if we had gone from 14,000 to 14,300 or 14,500, maybe then I would tell you, yeah, we had an extreme increase, but you're eyeballing data and you're telling me that going up 10 people is enough. So they said, no, we're going up. In terms of our enrollments, we need to start now making plans for having more buildings, better classrooms, getting all this money and resources so we can continue to grow. So this colleague of mine said, you know what? I'm really sorry. You guys are misinterpreting my work. This is not what we're talking about. So he said, my hands are clean out of this situation. I'm telling you that there is no increase in terms of a substantial amount. Yes, the numbers did go up, but it's not enough for us to say that is an extreme increase. I wash my hands free of this. So my colleague decided to quit his job and he left. And the university he was working for decided that they were going to request money to continue to build more buildings. So they were going to start working with the school, with the board of trustees, and working with the system that they were working with at that time, et cetera, to request more funds. So they started preparing all their documents and showing everything. And very interestingly, in fall of 2007, once they had started requesting money, and the other universities in their branch and in their area started kind of looking at the numbers, and the state started looking at their numbers, they went from 14,010 to about 12,100, let's say, for instance. So they went down quite a bit. So all of a sudden, people higher up in the university and people higher up in the state started looking at that and saying, okay, you've requested $1 billion, let's say, for instance, right? And your numbers are going down. I thought you were requesting money because you were supposedly growing. Well, we were growing from fall 05 to fall 06. We went up, but in fall 7, we kind of had a little bit of a down year. Well, what do you mean you had a little bit of a down year? And now the university started saying, well, we really didn't go down by that much. So now people started looking and saying, okay, well, first when you went up by 10, you said you're going up, but now that you've gone down by a lot, by over 1,000 individuals, you're now telling me you really didn't go down? So in one instance, you had an extreme increase, but here, oh, no, this is not an extreme difference. They're like, how is that possible? If this difference is larger than this difference here. So now all of a sudden they got in big trouble. So they call my fellow colleague who was no longer at that institution, and they start wanting an explanation. They start saying, okay, well, why is it that people were requesting money here, but our numbers are down here? And he said, well, that's what I told them. I told them to be very, very careful. I told them that we weren't growing. I told them from one year to the next year, we were not increasing. And in reality, they started decreasing. And then the following year, they went down even more. So their enrollments were even lower. And they started saying, well, what's happening here? Well, Other universities started coming into that same area and started competing. Other universities were taking students and offering better services in other places of the state or in other places of the country, and they were coming and doing more recruiting at high schools, and they weren't allowing students to go into their university, and they were going somewhere else. So those numbers started decreasing and decreasing and decreasing. So just to kind of bring the story to a close here, ultimately, no money was given to that institution. Why was no money given? Well, because they couldn't justify that their increase was actually significant. If they would have gone from 14,000 to 15,000, I would have told you, hey, you know what? We need to give them money because they need to accommodate for 1,000 new students. That's incredible. And I would have never predicted that their scores or their enrollments would have gone down if they would have had such a substantial increase. But looking at this difference here of 10 students, I would have agreed with my colleague and said there is no difference. That is not significant. It's not an extreme difference. And now this difference here, that is an extreme difference. That seems to be a very, very large difference between those two numbers. So here, this term significant is very, very important for us because it carries a lot of weight for us in statistical terms. When we use the term significant, it's essentially telling people there's an extreme difference, there's an extreme relationship between our numbers. So we have to consider that. So our first lesson in statistical testing, never eyeball data. We have to rely on statistical testing. Okay, so let's look here at statistical testing. So when we look at significance testing, we use the term null hypothesis significance testing. Now you're probably wondering, well, that's interesting. You talked about the null hypothesis on the previous page, which is right here, and now you talk about null hypothesis here, and you're saying null hypothesis significance testing. Why are you saying null hypothesis significance testing? Well, let's go back here very quickly. Remember that with null hypothesis, I told you that the null hypothesis gives me a value. What value does the null hypothesis give me? It gives me the value of a 0. Here, all I know is that the difference is not supposed to be equal to 0, but I don't know what my value is. So what is the differences between my groups? I don't know. But here, the null is telling me the difference between your groups should be equal to 0, the relationship between your variables should be equal to 0, etc. So I know what value I'm looking for here. Here, I don't know what I'm looking for. So think of it in mathematical terms. If we have an unknown, I need to solve for that unknown. But if I want to know if my value is different from another value, I need to know that comparison value. So think of it like in the following case. Again, we're thinking of exam scores. Imagine someone coming up to you and saying, hey, what did you get on the exam? And you tell them I got an 81. And they go, well, I'm smarter than you. What your conclusion is, or your inference here is, they must have gotten a better grade than me, but what was their grade? If you don't know what their grade was, can you ever really accurately draw that conclusion? So if you tell them, I got an 81, what did you get, but they don't tell you? How can you ever draw the conclusion that, yeah, they're smarter than you, or yeah, they performed better? You need to know this other value. That's kind of the same thing here. Here, I don't know what my value should be. All I know is that it shouldn't be equal to 0. But then what value should it be? I don't know. But here, I know what my value is. So in other words, if someone says, hey, what did you get? And you say, I got an 81. And they tell you, oh, well, I got an 89. Now looking at the differences between those values, you should then be able to compare that difference to the 0 and say, is that difference between these two numbers really extreme? Is that an extreme amount of difference between an 89 and an 81 for me to able to then conclude that the difference between these two numbers is extreme? That's ultimately what we're trying to say. How do I compare my value to an unknown value? I need to know this other value so that way I can then make my comparison. So here, I don't know what that value is. So the only one that gives me a true value is the null hypothesis, because it tells me what my value should be. It should be equal to a 0. It shouldn't be equal to a 1. It shouldn't be equal to a 2. Why isn't it equal to a 1 or a 2? Because again, I don't know if it's really equal to a 1 or a 2, but I can tell you that if there is no difference between the groups, the difference then must be equal to 0 if there is no difference. Here, if the difference is not equal or if the groups are not equal to each other, if they are different from each other, how much are they different by? I don't know. So potentially this value of an 8 may fall here. So the difference between the groups may be an 8, but I don't know that. So I need to first find out what my value is, compare it to a specific value that's already known, so that way I can then draw the conclusion if my value is extremely different enough from that other value that is known. In this particular case, the 0 given to me by the null. So ultimately, why do we call hypothesis testing null hypothesis significance testing? Because the null tells me what my comparison value should be. My comparison value should be equal to a 0. So if we go back here to z, z was telling me my difference between my mean and my population mean should be equal to 0. If my sample mean minus my population mean is not equal to 0, well then I've supported the alternative. But then I'll finally know what my value is. But I need to first know what my value is to be able to compare it to this 0 value, so that way I can draw a conclusion if my value is extremely different. So again, going back to this aspect of looking at the difference between an 81 minus an 80. So if you got an 81 and they got an 80, are you smarter than them? You're probably thinking to yourself, yes, I am. But no, in reality, you're probably not. That difference is probably due to error or just due to random chance. So here, I don't want to draw the conclusion that you two do really differ when in reality you don't differ. So I want to be careful with that. So ultimately here, with z, in our particular case, like our textbook explains, if, for instance, I have a z-score that is equal to 0.01, so in other words, my score, or the difference between, in this particular case, my sample mean and my population mean is 0.01, is that really different from 0? The answer is probably no. But I need to test that statistically to know if the difference between that number there and that number there is extreme or not extreme. And that's ultimately what we're going to do with null hypothesis significance testing. Now, null hypothesis significance testing occurs in 4 steps. Step number 1, we always state the null and the alternative hypothesis in terms of population parameters. So going back to this issue, we talked about it at the beginning of the lecture when we talked about null hypothesis significance testing, or when we talked about the null and the alternative hypothesis. The null hypothesis, remember, essentially stipulates that there is no differences between the groups, no relationships, no effect. The alternative hypothesis states that there is a difference, there is a relationship, there is an effect. Remember that your null and alternative hypothesis are always stipulated in terms of population parameters because the null and the alternative refer to the population. Those are the effects that exist out in the real world. So not in this pseudo world that I'm creating in my research situation, but rather in the real world, the 2 alternatives that may potentially exist are the null and the alternative hypothesis. So I always have to state them in terms of population parameters because they exist in the real world with the population, because the population is the real world. Step number 2, we're going to collect data, and we're going to calculate all descriptive and inferential statistics that are needed. This is a very, very important term, that are needed. A lot of people, whenever it is that we do statistical testing, many times researchers get very flustered and confused and assume that we have to calculate every single statistic that has ever existed in a textbook. The answer is no. You don't. And the reason you don't is because some of them are not useful to you for your particular question. So in other words, if I'm comparing traditional versus online classes, I have 2 groups that are mutually exclusive from each other. There's a specific statistic that I'm going to use to look at the differences between those 2 groups. Okay? There are other statistics that require me to have 3 or more groups. That statistic is not appropriate if I'm only comparing 2 groups, online and traditional. So here, that other statistic is completely useless to me and is not going to be useful to me. So here, I don't need to calculate it. So in other words, I only calculate statistics that are relevant to me and that are useful for me to answer my question. Now, once it is that I've collected my data, calculated my descriptive and inferential statistics as needed, I'm now going to begin testing my statistic for significance.